Hello and welcome again. So in the last session we discussed about regular expressions, some usages of it, the email validator, and we also discussed about web scraping, the libraries like Beautiful Soup and URL-lib and Socket. Today we are going to discuss further on web services and web scraping. Excuse me. Okay, let's start. So whatever you have any questions, you can again the same as before. We follow the same things. You put a question. I have muted you because okay, you can put a question on the question window and I will try to address that. Okay, let's begin with today's session. So we are discussing about web services. Let's see what is data on the web we are focused on. With the HTTP request response well understood. So last class we discussed about HTTP request and response, that is GET, and you get the response from the server. The GET request, which we did using the socket library, and we also did using the URL lib, and then we tried to parse the HTML response which we get from the server using Beautiful Soup. Okay, so what we are focusing on is the same thing, the data on the web. Okay, so we discussed about the HTTP request. Okay, now there's a natural move toward exchanging data between programs using these protocols. Now these are very in use protocols, very famous protocols. So all your data exchange, you can find HTTP in place. Okay, so we needed to come up with an agreed way to represent data going between applications and across networks. Like we discussed in our previous session, that we need to have a protocol so that it is well understood. Excuse me. It is well understood by uh, the parties on each side, that is the sender and the receiver, right? And that is why we got the HTTP protocol in place. Other than this protocol, we also need to have a common format of the data which we are going to exchange, so that so that everybody understands and have the same understanding about that data, so that we don't end up in a mess again that we are sending data, for example, in XML format. The receiver really does not understand about XML. Just an example, whereas we know that XML is widely used format and everybody understands that, everybody supports that, you know. So this should not happen. That is, there should not be miscommunication, and that is why we come to a conclusive point, conclusive format, data format, so that all agree to that format and all use that. Okay, so the commonly used formats, the data formats which all agree on, are XML and JSON. These are widely used data formats across the networks. Applications which are talking to other applications on different machines, they know that data is going to be XML or JSON, and hence they know how to parse it and understand it. Okay, so other than the protocol, what we understand from this slide is that other than the protocol, we also need to have a common understanding on the data part or the data representation part, and hence XML and JSON are widely used common data formats Okay. Excuse me. Okay. So the cloud which is drawn over here is your network basically, and the left hand side party is sending data in Python dictionary format, which is sent across the net, which is network, the cloud. It's not the cloud, I'm just saying it cloud. It can be any network. It can be wired network, can be wireless network, or it can be any network. So I would just use the term internet. Okay, so Python dictionary is sent from one machine across the internet to the other machine, which really does not understand Python dictionary. What it understands is Java hash map. Okay, so there is a conflict now. The machine sending the data is sending in Python dictionary format. The machine receiving the data does not understand Python dictionary, but it understands Java hash map. So the result is the receiving machine ends up misunderstanding or not understanding the data sent by the sender. Okay. Now what we say is we have agreed on a common format, common data format. So what happens now is there is a process called serialization, another process called deserialization. While sending, the data is serialized to a common understandable format. Say it can be an XML format or it can be JSON format. I'm sorry. Okay. So what happens in the serialization is that data, that is Python dictionary, is converted to common understandable format, that is XML or JSON, right? And while receiving, the receiver part converts it back to data which he understands. Okay, the data which receiver understands converts it from the common format to the specific format which receiver understands it. That process is called deserialization. So converting data from an uncommon format to a common format is serialization, while converting it back to a specific format from the common format is deserialization. This way, the communication is intact and both of them are able to send and receive the data in their own format, but they don't have to bother about what is going on while serialization or deserialization, but they understand the data now. Okay, so that was the XML format. This is JSON format. Okay. Okay, let's come to a very famous format called XML format and try to understand some basic aspects of it. Okay, what do you mean by XML? How it is, how the data is formatted in this, and so on. So XML is extensible markup language. Okay, the data is formatted in terms of nodes, and so nodes are the tags basically. Okay, okay, so over here what What I mean by a tag is something which is in the angle brackets. Okay, this is what I mean by a tag. So do you by any chance have learned about XML in your any courses? Yeah,
No, no,
not yet.
I don't have Excel. No.
Great, no problem. So I'll be explaining every bit and very basic of it. Okay.
Mm, okay.
Great. So let's understand this. Okay. So I was telling that XML elements are nothing but tags or nodes. This is what I mean by a tag, which is inside the angle brackets. Angle brackets is the tag, is called one tag. And I also call this as one node. Okay, this is my one node. All right. Now, inside a node, there can be child nodes. If this node does not have a child node, I call that node as a simple element, like the elements in yellow color, right? These do not have any child nodes. These are simple elements. What I mean by complex element is this, okay? Is this violet color thing. And why it is a complex? Because this has got a group of the parent node. Now this becomes the parent node. That's the parent node or parent element for these two childs, these two children. Okay. Now these children are of this parent. Okay. Such element for us, this is also an element. Okay. But this is a complex element which has got a group of parent and children. Okay. Here, these simple elements do not have any child, and that is why we call them as simple elements. Okay, and and how do I define the boundaries of one parent or one node or one element? In fact, so the tag which is I told that it is inside the angle brackets will also have an AND tag. So I will say now I have got two tags. I will remove this. I'll say this is my start tag, or let's remove all this and let's focus on. I say that this person tag is my start tag. Okay. The person with a slash in the beginning. The slash you see here marks this as the end of this particular tag. Now tag is person tag, right? But when you put a slash, forward slash before the tag name, that tells that now my tag has ended and hence my element has ended. Okay. So I say that my complex element person has started here and ended here. Okay. Now this person has got a name and a phone number. Okay. And name is yet another tag which has also got, so remember, every start tag has to have an end tag. Otherwise, the XML is incomplete and will throw errors. Okay. The formation of XML is based on tags. The tags have to start, the tags which have started have to end. Okay, whether it be a simple element or a complex element, the tags have to end if they have started. Similarly, if you see the two tags, the two complex elements, one element is this one, the first person, which has the tag name and value as Chuck. So I would say the Chuck person and Noah person. These two person belongs to the parent category, which is people. So my XML has got two people with their corresponding attributes and values. All right. So what do you understand from this is XML is based on tags, and you end the tag if you have started the tag with a forward slash before the tag name, and you put a tag basically inside angle brackets and give it a name inside the angle bracket. All right, this is simple. Let's move further and understand further things on XML. Okay. XML is marking up data to send across the network. Okay. The further explanation on XML, if you want to have a look, the link is mentioned on the slide, which is Wikipedia link. You can go in detail about XML if you are interested. Okay. It is, as I said, the full form of XML is Extensible Markup Language. So the primary purpose is to help information systems share structured data. Now data in XML is very structured, right? You can see I can clearly identify what data this XML has with the help of tags. It becomes very simple for me to understand the data which is going in this XML format. So share structured data. Such is the structured data. XML is a structured data. Such structured data is very easy to understand and is accepted by all communication mediums. Okay. It started as a simplified subset of standard generalized markup language. So it was, started after the generalized markup language. So basically it's a subset of this language. XML is subset of SGML, okay, and it is intended to be human legible, okay, so that we as humans, the easiest way to understand is a common language where everybody. So mostly if you see is the English language which is accepted all around the world, and whatever is close to English is mostly accepted by people across the world, right? So it is very well understood, XMLs, and it is very structured. Okay, here we come to the basics of how the structured XML can be identified, how the various parts of XML can be identified. Okay, so they have got something called start tags. As I said, you can see in the green color, these are all start tags, the person, name and phone, and corresponding to each start tag you have got end tags. Okay, and one more out here, I will draw it like this. Okay, so for each start tag, person is the start tag and slash person is the end tag corresponding to it. Similarly, name, start tag, and slash name is the end tag corresponding to it, and so on, right? The text content is what is the data corresponding to that particular tag, right? For example, what you see in white color, let me just remove all these lines. Okay. Okay, and more, what we are now talking about is the text content, the data which is carried by each tag. Name of the person is Chuck. The contact number of Chuck is this, right? That is the data corresponding to tag phone. This is the Chuck is the data corresponding to name tag. All right. Okay. We have something called attribute also here. Attribute is nothing but an extended type for each tag. For example, we are saying that what sort of phone number am I talking about? Okay, I want to get more in detail about this tag. So I have given this an attribute and a value. So that type becomes my attribute. Let me again remove all this, and what I mean is type here becomes the attribute for tag phone. Okay, and INTL, which is international, this becomes value for attribute type. Okay, type is the attribute corresponding to the tag phone, and INTL international is the value for the attribute type. Okay, similarly here for email I have got an attribute called hide, and this signifies that it has got an extended meaning for this tag, so that email is hidden, right? So I am saying I'm qualifying it further. I'm qualifying this tag, which is email, further to make it hidden. So I'm saying that yes, it is an email. Okay, yes, it is an email, but the email is to be hidden. Okay, now there is something called self-closing tag. Okay, this tag is of the form that it has only got attribute, but it really does not have any value. Just an example, of course it might not be looking that valid in this scenario where the person does not have it. It is also of course possible that the person does not have an email address. Okay, but if at all, if a person has an email address, you can give, of course, mention in the with the help of start and end tag. So in that case, this slash will not come over here. Rather, you will start the tag like this in the normal case. Even though if you want to add an attribute to that tag, that's very much possible. In this case, there is no email address, and hence it is called a self-closing tag. Okay, these are the very basic elements of an XML formation. Okay, all right. Now here is the same example, but some extra meanings of here. Let's understand what are the intention for these slides. Line ends do not matter. So for example, it is not mandatory for me to write this phone number uh, in single line itself. Okay, what matters is whether I am opening the tag and closing the tag properly or not. For anybody to understand and or extract data from an XML, the tags would be taken into consideration rather than spaces or line breaks and so on. Similarly, white space is generally discarded on text elements. Even if you give a white space over here, mostly it is discarded. Okay, we intend only to be readable. So why we have put this uh, phone number on the next line, so that it becomes more readable and you don't end up creating one physical line to be this long, right? So it is always a good idea to make your code very visible. Okay, and that is why we break our XML to be better readable, right? Okay, similarly example is shown below that both have the same thing. They really do not vary in any case. It is just the representation part of these two XMLs. Both are XMLs, but just the presentation is in one line over here and in two or three lines here. Right? Any doubts so far? Okay, no, that's great. Okay, let's proceed further. Now that's a very a little bigger, not very, it's a little bigger XML, which is just an example like how the actual XMLs would look like. Okay, now that's an XML with a recipe, right? That's an XML with a recipe. And what is the recipe for? Okay, the recipe is for basic bread, right? So you can see that the recipe is for, the title is basic bread. Okay, in fact this recipe has got some attributes. The attributes are like what is the recipe name, and the preparation time is 5 minutes, the cooking time is 3 hours, and it has got the complete items which are required, that is the ingredients. Okay, amount is 8. I'm not sure what amount it is talking about, 8 spoons or 8 bags, I don't know. So it is just an idea. Okay, so here it is next. Now I can see it. So amount is 8 and unit of that amount is DL or grams or teaspoon, or what is the state of this particular attribute. Okay, and you will find that this XML is really very easy to understand once you get the basic elements in place, once you understand the basic elements of the XML. And hence at the end you would find the instructions, and you would find the instructions to prepare this recipe after the ingredients are in place. All right, this is about the XML, and this we already discussed. Tags are to indicate the beginning and ending of elements. It can be simple elements, it can be complex elements. tags are very important. Now there are two types of tags. One is start tag, another is end tag. We also discussed the third type of tag, which is self-closing tag. Okay, great. Attributes. What are attributes? Attributes are like keyword value pairs on the opening tag of XML. Okay, and where are the key attributes placed? The attributes are placed in the opening XML, opening tag of the XML. So you see here, these tags are not placed, and sorry, these attributes are not placed in the end tag. Okay, these attributes, what you see, amount, unit, this is placed in the opening tag itself. Okay, the attributes are placed in the opening tag. Now serialize and deserialize. Convert data in one program into a common format that can be stored and or transmitted between systems in a programming language independent manner. Okay, so it is very simple to understand. You are converting the data, okay, into a common format. That's serialization, right? Or basically deserialization is also, but in the other way, that you reconvert it back to the original form or in a different form. Okay. Okay, let's understand this XML as a tree format. So as I was talking about the parent and child relationship, where you remember that for me, A is this element. Okay, this complete part of the data belongs to the parent A. Agree on that? Yeah. So since the start tag is here and we have got an end tag, whatever is inside this tag, whatever is inside this tag belongs to A. Yeah, is under A. A becomes the parent for all of these. Now where is B ending? You see, B is starting here and B is ending here itself. So B becomes an independent child of A, right? So B becomes a child of A. Now B has got a value, that is, it has got some text or a value corresponding to the tag B. That's why we have shown this in pink color. Okay, so X is the data which is part of B tag. Similarly, now C is starting here, but C is ending here. This is important to note. Now C is not ending here or here. Now C itself has got two children, right? D and E. Because C is not ending here, it is ending after D and E have ended. That means D and E become the children of C. So D and E become the children of C. But C in fact is child of A, right? And D and E have got values Y and Z. Okay. If you can understand this XML in this tree format, you will very well understand the complete XML if it's presented to you. Any XML. Okay. All right. Now let's understand how we place attributes. So we have placed attributes in the green color, which you see is corresponding to tag B. Okay. Attribute is in green color, and pink color has the text of that node. All right, now let's see how we can interpret them as a path. Okay, so how many paths we can interpret, or what is the path we can go and fetch the values. See, our ultimate goal would be using these tags to get to these values, right? What are the values? X, Y, Z are the values which we would be interested on. Okay, so if you go to the path starting at A and ending at B, where would you reach? You would find the value X. For getting to Y, what is the path you will have to take? Can you figure out different paths, or do you see a single common path? Yeah, Yan?
Hmm?
So for reaching Y,
ACDE.
ACD, right? Do you see
Yes.
any different path?
No.
No, right? So you cannot reach Y in any different path. Okay.
Mm.
And as our ultimate goal is to figure out these values X, Y, and Z, right? And these have got paths. Why we are telling these as paths? Because when you have to parse any XML parts, right? When you have to fetch,
Mm.
or parse an XML,
Mm.
these paths would be your guide. Okay, these
Mm.
paths would be helping you on fetching the data. Okay, and we will see how do you do this using Python. Okay.
Okay.
Okay, great. So since it is now confirmed that we cannot reach Y in any other path, so we need to understand the path format. So similarly is this for path for Z, which is A, C, and E. Okay, let's move further. XML schema. What do you understand by a schema? It's a contract basically. Okay, and when you say, so I mean that schema refers to a contract. Now XML schema refers to a contract which says that what is the acceptable XML. It is basically validating an XML, whether it is a valid XML or not. Who describes this contract, right? Who would describe this contract? Now, this contract is described by the parties who are communicating through XML. We will see how. There is a common format which everybody has to agree on, that is the general XML schema, right? But there are specific schemas which individuals are free to follow, and but that has to be shared, that has to be made as a contract so that both agree on that, and that's what is meant by schema. Okay, so here comes the different points on XML schema. Description of the legal format of an XML document expressed in terms of constraints on the structure and content of the documents. So what all this schema or the contract describes, it describes that what should be the structured way for this particular XML, right? If, for example, let's say we have two parties, party number one, party number two, they want to communicate over in XML, right? But they say that I don't want to follow the only the generalized scheme. whereas my schema is focused around communicating about people, say for example. Now I will define that how my people structure has to look like. For example, how many tags have to be there, like attributes have to be there, like whether people will have, every person will have names or ID something. So that is what is meant by schema, that they come to an agreement that this is my schema which will be followed by both of us so that we can understand this XML. All right. Okay, that is what is written over here. My system will only accept XML. Now understand this part, very important. Now they're saying, yes, I understand XML. Now party number 2 says, yes, I understand XML. But party number 1 is saying, understanding only XML will not work out. You will have to conform to the contract which I am telling you. That contract says, you need to conform to the particular schema because I want to send some specific informations. So my system will only accept XML that conforms to this particular schema. Okay. Now if that particular piece of XML, okay, now these two people, that is party number 1 and party number 2, they share a XML schema. Okay. Now they know that if any XML sent by any of these guys, whether 2 is sending 1 or 1 is sending 2, both have to conform to this schema. Only if they conform to this schema, that XML is said to be valid XML. Okay. Until then, it is invalid. Okay. All right. So now XML schema is important to understand. That is meant to be mostly for your validation part of it or defining a contract between the communicating parties. Okay. Now that's what is, pink color validator, right? That's a box which validates any XML. And how does that validate? Now that box is given a schema, that's the contract, and the document which has to be sent. If this document conforms to this schema, this validator is going to pass or validate. Otherwise, it is going to fail the validation and you might get a lot of errors. Okay, that's the part of XML validation. So we discussed about basics of XML elements and about the validation of any XML. Okay, great. So that's the part of it. Now you can see how a typical schema or a contract looks like. Now there is this schema which is corresponding, or the opposite way rather, this XML document conforms to this XML schema. How does that confirm? We will see that. Okay, so it confirms in the way it has got the attribute as person. Yes, it has got a tag with person. Okay, it has also got last name. Okay, the age, date born, you can see all over here, and also the type of the data which this tag is supposed to take. For example, you cannot give an integer to this tag, an integer value for this last name tag. So, and that is why this schema is giving the detail of the type which it accepts. This last name tag accepts only strings. So you should not give any integer value for this tag. Similarly, for age, the type of the data is set to be integer and so on, right? Okay, so you understand this part, how this XML is confirming to this contract or schema. Is this clear? Okay, that's great. Okay, let's move on. Okay, now we come to XML schema languages. There are different sort of languages which define the contract. Okay, but the most used is XSD. Okay, the other types are document type definition, DTD. So you can go through DTD and other things. We are not talking about that. If you are interested, the links are given on the slide as usual. You can go through them if you feel you need to get more idea on that. The other one is standard generalized markup language for SGML. Okay, these are schema languages. Okay, and there comes XSD. Okay, that is XML schema from W3C. Okay, W3C is a consortium which handles all those things. Okay, you can go through again. You can go through the W3C standards on the Wikipedia and the given link. Yeah. Now we are going to talk about the most talked or most used schema format, which is XSD. Okay, and W3C, it's a W3C spec. W3C is World Wide Web Consortium. Okay, it is often called W3C schema. Okay, more commonly it is called XSD because the file names for these schemas have the extension .xsd. The file names for these schemas is .xsd. Okay, and that is why mostly it is called XSD schemas rather than W3C schemas. Okay, now this is the typical format of an XSD file. Okay, similarly, the colors are mentioned over here. You can see this belongs to this element part, the orange color. Okay, what do you mean by a sequence? That it is a set of items. Sequence, we say that now this person tag has got these particular set of items. Each person will have sequence of these many items. Okay, all right. And also we discussed why it is called a complex type, because yellow color. This person tag is called complex type because this has a group of items under it, or it has got children. Okay, all right. So any problem in this particular slide? Yeah, we have already discussed about the type. We can define the type and the element. See, you can really go through. I might miss some part of this because it is really vast thing to cover in one session, but I'm covering the most important aspects of it. If you really find that I missed on something, you can go through it. Okay, all right. Okay. what is a sequence? Okay. Okay, let me go back again in the last slide. Sequence is nothing when you know that it's a complex type. Okay, complex type in the sense it has got uh, these many items. Okay, we are saying that this complex type tag, basically type of the tag is complex because it has got children under it. So, and children, like, it's a set of these items, and when we say set of these items we define it under the sequence. Okay, is this clear now? So all your set of uh, uh, all your children will be defined under a sequence. Okay, can we add the sequence tags in the first person code block? Okay. Excuse me, I got your point. So what this means is not the tag name. Sequence is not a tag name. It really does not convert to a tag. For example, this complex type and it has got a tag name. This basically is your tag name. Okay. Now this tag name actually converts to a tag. Okay. Whereas this sequence in green is just for defining, is just part of the contract, is just part of the XSD file. Okay, it really does not convert to any tag over in the actual XML. Okay, so sequence will not convert to any tag. Okay, that's just part of our XSD file to define that it has to be a set. I'm sorry. Yeah. Okay. Okay, shall we proceed further? Okay, great. Now let's move on. Okay, here comes some more part of it. Okay, and this says XSD constraints. Okay, there are certain constraints which you can define for an element, right? Like this element which is in cyan color, this color. Okay, it is of the form string. It is supposed to be of form string, and it can occur minimum one time, maximum one time. So basically we are saying that this tag has to happen only a single time. Okay, that means full name, that is name of a person, has to happen only a single time. You cannot write down in your XML full name again. Okay, so I cannot give, for example, I cannot give in this place. So just after the full name I cannot give again a tag with full name. Okay, that occurs only a single time. Similarly, there are many constraints which you can go through in the given link. Okay, the constraints are basically to restrict the definition of an element. Okay, so you constrain them on certain areas, like you constrain them on string or the type of the data which they can hold, or the number of times which they can occur in the XML, and so on. Yeah. Okay. Okay, these are certain data types which a typical XML could have. So one type is, you can see, is a string type, and it is confirming to here. You can see all color coding is very good to explain things. Okay, So this thing says it is a string. Then you have got the type of date format. Then you have got date time format. Okay, and then you have got decimal format. Okay, and then integer format. Okay, you can go through each of the things in detail. Okay, very most common of, and what, see, basically you should understand the idea behind the formats. Okay, there might be a number of formats, they might be adding new format, but what we are focusing on is understanding the idea behind data types, the constraints and validation, right? The concept should be clear to us. Okay, great. That's a typical, ISO date time format. Okay, so time zone is mostly with respect to UTC and rather than the local time zone. Okay, and again the Wikipedia link is given. You can go through this ISO 8601 and understand how exactly these time zones work and represented. Okay. Okay, great. So this is just again a very typical XSD file and an example XML file which is conforming to this XSD. Okay. All right. You can go through this. Okay. The XML which is shown here, this particular XML over here, this conforms to this XSD. Okay. All right. Okay, one more important point which you see is enumeration, right? As I said, there will be multiple things as part of XSD. We are not covering all, but I will explain you what enumeration is. Enumeration is nothing but we are specifying certain specific values for this type. Okay, so we are saying that countries, this country tag can have values only one out of these. It cannot have any string. Yes, though it is to be string. You cannot give any number for this. So for example, let's take the example over here, which is converted to UK. Okay. Now it cannot be given a value of, say for example, if I remove this UK and give a value of 5, okay, that's really not valid. It has to be string, but what sort of string? That's what we are defining here. We are telling that it has to be only one out of these 5 countries. Okay, so there might be different scenarios where you want to define your schema or the contract, and you might use other things which are not listed over here. Okay, great. So this is again one more sort of schema where you have a group of items again. Okay, you can go through this and understand this. Yeah, all right, now we come to the part of how we can use XMLs and how we can parse them in Python. Okay, the library is named as XML. Okay, this is again one sort of XML parsing. There might be third-party libraries which would be doing this, but we are focusing on one certain format, okay, one certain usage of it. Let's see if I can demo this to you. So let me put this if I don't have in that case. If I not put, give me a minute. Okay. Okay, let me save this file. So what I would do is keep this and copy this code. All right. Most of the codes should be working. Okay. I would just paste it in a new file and name this as save this as XML, or do I already have it? No, I don't have it. So XML parsing.py. All right. Now let me run this and see. Okay. All right. So you see, let me explain you this code now. Okay, so you see the output over here, which is saying name is Chuck, attribute is yes. Okay, let's go one by one. So the code you see here is part of the XML library. So let me just show you. Okay, so you can do import XML. That works. Yeah, that means XML is a built-in module given by Python. Okay, and what we are trying to do is we are trying to access the element tree. Okay, we are trying to access the element tree object. Yeah, and we have given the data as one XML. Okay, this data is given in the string form as an XML, a small XML, which we want to parse and figure out what is the value for the tag name and what is the value for the tag, not tag, the attribute value in fact. Okay, and what is the attribute value we are looking for? So let's see. So once we have got the element tree, this does not, this what basically it does is it will get the data, it will convert this string data into a tree format. Okay, it will convert this into a tree format from string. Okay, so et dot from string, so from the string, and which data, the string we have given as input. Okay, from this string get me a tree so that I can refer them using dot notation. So where I'm doing now, so I'm trying to find the node with value name. That means I am going to the tag name and I'm getting the text corresponding to this tag. So immediately the text corresponding to this tag, which is Chuck, is printed. Very simple, right? Similarly, if I want to get an attribute value for that tag, so I would go like this, tree.find. So let me go to the tag email and get the value for the attribute hide. All right, that gives me two prints. One is the value for the tag name. One is the value for the attribute hide. All right. Okay, this is very simple sort of XML parsing, but very powerful. Okay, isn't it simple? Yeah.
Yes.
Yes, right. So
Yeah.
we would be doing a project based on all these things so that you are aware of all the aspects of Python programming. Okay.
Okay.
Okay, great. So let's move further. Yeah.
Okay. Okay.
Yeah. So this was a very simple example on how XML parsing is done. Okay, let me close this and let's get back to our slides and we were here. Okay, another example where we have got this a typical no, a bit longer XML rather. So we have got this element called users. Till now we had only single element, right? A single person. In fact, we had only one person with name, phone number and email ID. And now what we have got is multiple users, not one person. We have got multiple persons, one user here, another user here. Okay, both have got ID and name. Now this example is to showcase how you can use Python loops to get all the items. Okay, so as before, we will be creating a tree first of all. So stuff is my tree now. Okay, now this stuff tree, we were using the method find so far. Now since we want to get further more details and for all the users basically, so we will use the method find all. Okay, and you need to give something like this, okay, wherein you say I want to find all users. So the tag users will be found and all the users inside this will be coming as a list. Okay, that's a list of all users. Okay, yeah, and then we are saying that okay, let me, okay, you have a question which is why we use after input instead of, okay, great question. Okay, I appreciate you have a good question. Let me answer that. So why we are using this triple quotes over here instead of double quotes? Okay, so since we are defining this XML in the form of a string, okay, now your XML itself can contain strings, right? So you see over here this XML has double quotes. If we use double quotes over here in this place, if we use double quotes, what Python would think is this as the end of the string. The string would end here itself in this particular part, right? So we have three ways to represent this string. One is single quotes, one is double quotes, and one is triple quotes. Okay, if we have single quotes in the data itself, we don't use single quotes to define strings because there is a mismatch of start and end of the string. So we use double quotes. If you see that you might use both of these as the data, define your string using triple quotes rather than single or double quotes. Does this clarify? Yeah, okay, great. So now we have defined our XML inside this string. Okay, and then what we are doing is we are forming a tree. Okay, and we are looping through the tree to get all the users, okay, as a list, and then looping over each user, try to get the name of the user, try to get the ID of the user, okay, and try to get the attribute value for that user. Okay, this showcases that how we can use loops to get to all our nodes and tags and get the values. All right, so I won't run this. This is very simple. You can get the slide and copy the code and try to run this yourself. Okay, let's move further. with the other type of notation, which is called JSON, JavaScript Object Notation. Okay, JSON one, the notation, the data format which we discussed so far was around XML. Now let's discuss something on JSON part. Okay, so JSON was discovered by Douglas Crockford. Okay. So object literal notation in JavaScript. Okay. Okay, this is nothing but some books. Okay, that's the official page of JSON, and which gives you the exact definition of it. Okay, so JSON is lightweight data interchange format. Okay, it is easy for humans to read and write. As we discussed that we are using, and world has accepted these two formats because of their simplicity. They are very easy to understand, but parallelly they are very well structured also. JSON is built on two structures. Okay, two structures. So first of all, what is JSON? JSON is lightweight data interchange format, easy for humans to read and write. Now how it is built around? It is built around two structures. One is collection of name value pairs. Okay, this is basically realized as an object, record, structure, dictionary, right? So what you can see is a collection of name value pairs. We know that our Python dictionary is what? Collection of key value pairs, right? So this is what is one sort of structure which JSON is built on. Okay, another is list of values, an ordered list of values. This is in languages it is realized as array, vector, list or sequence. In Python it is called list, and here it is called dictionary. So JSON is built around these two structures. So as you can see here, you might find, not might, you will find these sorts of things around JSON. Okay, one is in the dictionary format, one is in the list format. Okay, let's see how we can see. Okay, again in Python there is a library which is called JSON, which is used to parse JSON files or JSON data. Okay, now again we have got a sample JSON data in the form of string. Okay, for our quick testing, this is very handy that we use we define a string and a JSON inside or an XML inside that. As you can see, this JSON is built around dictionaries. Okay, now we have got this outer dictionary. This is the first dictionary which has got key value. Now this is the key, this complete is the value, isn't it? Okay, again this is the key and this is the value, key and value. Okay, these are the key value pairs, and this ends here. Is something missing out here? I don't see a closing tag. Am I missing? No, that's fine, that's fine, that's correct. So this particular is corresponding to this one, and this is corresponding to this one. Okay, so we have got all closing items. Okay, now this particular JSON we are talking about is built around only dictionaries, that is key value pairs, and we have got 3 keys and 3 values. Okay, let's see how do we parse this JSON using our JSON library. Okay, so you import the JSON module. Okay, and this is the method which will load your JSON. Okay, and create a JSON object. That's the JSON object. Okay, using this JSON object, referring to its items is as simple as referring to a dictionary. Okay, So what you do basically is any time when you want to parse a JSON, import this JSON library and use this method json.loads, give the data in a string format, and it will create a JSON object. And then you can refer using this JSON object the elements of it. So my JSON object is info. I'm saying that, hey, get me in this object. If you have any name, please get me that. Okay, that prints what? Chuck, isn't it? Similarly, if you know that, obviously you would be knowing the confirming format here. Okay, JSON also has confirming format. So I'm saying that, hey, I know that this person has got email. Okay, and this email has got another attribute which is height. So get me the value for that. Okay, these are all very simple but powerful types of parsing the XML or JSON data. Remember the libraries, XML, JSON libraries, which are very handy to parse these data. Okay, let's move. This is the second example where the same as our previous XML example, now we have got a list. You can see now this JSON is confirming is built around list. As we discussed, your JSON can be built around two structures, key value pairs or ordered list of values. This one was key value pairs, that's in the dictionary format. The next one is in the list format. So we have got a list of items. How many items do we have here? So if I talk on the part of our Python lists, so how many items do you see in this list?
Two.
Two, right? So I'm talking about the list, and you know that list is surrounded by square brackets. My list is starting over here and ending right over here. Okay, and these are the comma separated items, right?
Yes.
These are the comma separated items, and this is another sort of how JSON is built on. Okay, the loading part and accessing part remains the same. Okay, okay, so you can go through this example when we share this slide and try to run this, then you get a confidence on parsing JSON and XML. Yeah,
Okay.
okay, great. So let's move on further. All right, okay, here we come to now, since we have discussed about a common format, data format, which the parties or the machines can understand, right? Now we're talking about something around services. Okay, how your services are organized or what your services are, right? Most of your non-trivial web application, they use services. Okay, they use services from other applications. Okay, so credit card charge, hotel reservation systems, okay, they use services from other applications. Okay, so what is understood by this slide is this is a cloud. Okay, this is a cloud of services, right? It has got bunch of services which this application is using. This application is using all these services to meet its goal. Similarly, there are some certain common services which will be used by applications around the world. Okay, and these services are published. Okay, So every service will publish the rules. Okay, service will publish the rules. So one of each of the service over here, service number 1, 2, 3, each of these services will publish its own rule that application must follow to make use of the service. Okay, it will tell that, hey, this is how you need to use my services, and those rules are nothing but APIs. They are called APIs, interfaces, right? Application programming interfaces, where this interface is nothing but the rule to take these services. Okay. Okay. Now, initially, two systems cooperate and split the problem. As the data service becomes useful, multiple applications want to use this information and application. Right. So, as and when your system grows, uh, multiple people would be needing to use the service, the same common services. Right. If you have multiple system in place, there might be a scenario where every system wants to use the same service to accomplish its task. All right. So there are some services which are called web services. The description you can find on the following Wikipedia page. Okay, let's talk about the APIs. Okay, API itself is largely abstract in that it specifies an interface and controls the behavior of the object specified in that interface. Right. As we discussed, APIs are nothing but the rules exposed by each service so that application can use those services. Okay. Software that provides the functionality described by an API. Okay. So any software that provides the functionality described by an API is said to be implementation of that API. Okay. An API is typically defined in terms of programming language used to build an application. Okay. So APIs are nothing but interfaces to access your services. So services will be offering something in each in their part. So APIs are the gateway to access that service. Okay. We have got some technologies for the services, web services. Okay. The two of the most used technologies are SOAP and REST, Simple Object Access Protocol. Okay. It's a note here. Okay, Dr. Chuck does not like SOAP because it is overly complex. So these days, REST, representational state transfer. Okay, these web services, REST services, are very much in use and popular. Okay, so these are nothing but remote resources which we create, read, update, and delete remotely. You can sit from your system and use these common services. Okay, which is focused around resource. We are not going to go again in the detail on how REST is used, but I would recommend, if you are really interested, as usual, go through it and in detail, follow the Wikipedia link, read about them. Yeah. Okay. So this is the API which we'll be doing an exercise on today, and we'll see how these APIs, which is exposed by Google, okay, to figure out the longitude and latitude, convert the addresses basically into specific longitude and latitude coordinates. Okay, these are the geocoding APIs. As we said, APIs are ways to access the services. And what are the services which you are trying to access here? We are trying to access the geocoding services of Google. Okay. So Google has exposed some APIs for developers to use and implement on their applications. Okay, let's see how it is. So if you go through this, you can see that the result, this is nothing but the response. Okay, what you see here is the JSON, isn't it? We discussed just now. It looks like a JSON format, isn't it? Now this JSON is the result of an API request. All right. Now, in fact, what is the request? That's the request. This is nothing but the request. That's a web request you made to the geocoding API. That's the path to this maps API geocode. Okay, and I want the result in JSON format, and the address is Ann Arbor. Okay, MI. Okay, I will demonstrate this so you get to know how actually it works. Okay. But just to understand that this particular piece of code, what you see here, is the result of the API request to get the geocode services. Okay, let's move further. Here is the code which we need to understand. Okay, now what we are making use of is in the previous session, we tried to use URL lib, right? And we learned that URL lib internally makes the socket connection and does the get request and all for us. Okay, we don't have to worry about the socket connection between the server and client. Okay, so we will be making use of these two modules, which is URL lib. So URL lib is to do all get request and okay, to request to the server. JSON is to parse the result JSON, right? Result JSON from geocode, right? In this case, geocode. Okay. So we know that. Okay, this is what is the link to access the geocode APIs. Okay. Okay. Now we know that this is the service URL. We are going to use the services of geocode, and we know this path. Now we are running this in infinite loop that because I want to know the location for multiple the exact longitude and latitude locations or the coordinates for different addresses. Okay, so what I'm doing first, I'm taking the location address as input from the user. So if the length of the address is less than 1, I don't want to, so that probably is not a valid input. So I would say this is invalid case. Okay, invalid input. So break. Okay, next, if it is not invalid, let's proceed with finding this latitude longitude coordinate for this address. So what I'm doing is I'm making a complete URL. Okay, giving the attributes and all. So how a complete URL is formed? I'm appending service URL with URL encode. Okay, now what this does is it gives the further attributes to this API. So this URL gets these as okay, since okay, this is what it is done. So I'm passing attributes to this. Now this becomes this part which I'm highlighting till here becomes the service URL. Okay, till the JSON, this becomes the service URL. Okay, now furthermore, I need to give the attributes and values for which I want the data. Okay, so the attributes are sensor, whether I want to use the sensor, or what is the address for which I want the details, and so on, right? I'm saying I don't want to use any sensors right now, and this is the address. What is the address? The address is what we have taken from user here. Okay. Okay. As usual, now we are done with our complete URL. Okay. What is my complete URL? Is the service URL plus the attribute values. Okay. I need to give attribute values because if I don't give, that might give me some default geocode values or something, right? So that's why I'm passing the address things. You can play around with this. Okay. I will showcase you, in fact, a working code. Okay. Next, what I'm doing is I'm doing a GET request. You remember in our last session, we tried this URL open. Giving the URL, we tried to open the connection and do a GET request, right? And then I'm trying to read the complete data. I'm sorry. Okay. So can you tell me, yeah,
Mm.
what is it that you get after this read? Yeah.
The document on the of the URL,
Mm-hmm.
the things on the web page,
Sorry, I didn't get you.
and the data on the HTTP web page.
The data on the HTTP web page, right? And
Yes.
okay, so what you get basically is this JSON, right?
Mm. Mm.
Right? Because we saw that
Mm.
the result of this request, right, HTTP page request, was
Mm.
this JSON file, isn't it?
Mm. Yes.
So this JSON would be the data out here. All right.
Mm. Okay.
Now we need to parse this data, right? Because we only want the what do you say, the latitude and longitude and details, right? We don't want all this stuff in this JSON, right?
Mm.
So we
Mm.
basically want to parse this JSON and get the important information what we are looking for. Okay. And what do we
Mm.
do? We would use the JSON library, isn't it? So we would say
Yes.
load this and see we are converting this to string because we need to conform to the method arguments, right? Type. So we are creating a JSON object, okay? And we
Mm.
are seeing if this is none. If this is none, that what does that mean?
There's no file,
I mean, that's
no
not
result.
invalid, right? That's an invalid.
Mm.
So it's
Mm.
something is we can print that, okay, I failed to retrieve or something, right?
Mm.
Okay. And we are printing the dump of it. What went invalid in that, right? If at all, something is that, right?
Mm.
So what we are concerned about is now we have got what is JS here now? JS. JS
Mm. Is the
is the JSON object, right?
yes.
After loading the data, we have got the JSON object. Now we know from our previous examples that uh, we can access the JSON data using the same like dictionary format, right? Uh,
Yes.
get me the ID of the item, right? And item
Mm.
was the JSON object, right?
Mm.
Okay. Now let's see how do we get that here. So we said, I'm sorry. Okay. So JS is what? The JSON object. I want to get the results. Where is the result? Here, right?
Mm.
I want to get the results of zero. Results of zero is the first one, right?
The first one.
The first one.
Yes.
And on the first one, I want to get the geometry. Where is geometry? Geometry is here. And in the geometry, we want to get the location. We want to go to the location and in the location we are going to the latitude value, isn't it?
Mm.
So once you create any XML or XML tree or JSON object, it is very easy to access the items in that, isn't it?
Yes.
Okay, great. Now let's see a running code of it. Yeah, let me just demonstrate this to you. And where do I have this? Do I have this? Mm, okay, let me open the file. I should have that. Geocoding, yeah. I have copy pasted the same code over here. Okay,
Mm.
so you can find the same code in our slides, which will be shared to you. Okay,
Okay. Okay.
let's try to run this. Very interesting part of it. Okay, give me a location. Tell me a location.
Mm.
Uh, University,
Chicago.
Chicago,
Okay.
Chicago, right?
Mm.
Okay, all right. See, it has given me right.
Oh.
Chicago, IL, USA, isn't it?
Yes.
And
Yes.
you have got the latitude and longitude exact location. Okay.
Mm.
Okay.
Yeah.
Let's try for some invalid address.
Mm.
So let me give what? I don't know. Maybe uh, something bad class. Oh my God, there is something called glass also. Okay, that that gives me an address. Okay, that's
Okay.
bad. Okay, let's try for some valid addresses. Okay, let me give for invalid first. Okay, pen, please. Oh my God, that's in India.
Mm. Yes.
Okay,
Let's try some numbers.
okay, pen is in Maharashtra, India. All right. Okay, let me search for Bangalore. Right, I'm in Bangalore. Okay, great. Side.
Mm.
That's in
Mm. Yeah.
Karnataka, India with these. Okay, in fact, it gives my exact lane address. Okay,
Oh, wow.
if I type in, say for example, now if I type in my address, G1
Mm.
Nagar. All right, see,
Wow.
I just typed in G1 Nagar, right? And
Yes.
that gave me complete address of it, right? G1 Nagar, Bangalore, Karnataka with pin code and the country.
Mm.
Okay,
Mm.
tell me some other location. I
Yeah.
want to try this. I'm very interested in. It's fun actually. Yeah.
Mm. Mm.
Uh,
Mm.
tell me your city location. Maybe you can find out that.
Okay.
Uh,
Jan
you need,
January Ave January Avenue.
uh,
January. The month January.
oh, January.
January
Yeah,
Avenue. Mm. St. Louis.
here it is, isn't it?
Yeah.
I just
Yes.
gave January Avenue, and see,
Mm.
it gave me
Mm.
St. Louis,
Yeah.
isn't it
Yeah.
good?
Yes.
Yeah. So,
True.
so you can use this geocode APIs exposed by Google, okay, to
Mm-hmm.
build very very cool stuff. Okay,
Mm. Yeah.
okay, that was a very short and very strong code, isn't it?
Yes.
It's a working code, it doesn't break, right? It keeps on asking you
Mm.
the locations, and it is so powerful that you get exact. So if you are stuck and you want to make an app, okay, which gives people short help, right, quick help on where on to find or to send. Say for example, there is a emergency, right? And if police or the people are trying to find you, they will try to locate using the latitude and longitude, right? um, or the complete address or something, right? So that gives you a very quick help on that, right?
Yes.
So that is a cool stuff, and let's stop this. So I hope you liked this one. Yeah,
Yeah, yes, it's really, really fun.
that's a fun part of it. Yeah. Okay, so you can do one thing. Try your hands on this code. Okay, I'll be
Mm,
sharing this slide as soon as possible. Again, okay,
okay.
and
Mm,
you just copy paste the code, and also you can do is that try to tweak this code to make it better.
mm,
Yeah.
okay. Okay.
Okay. Let's move what we have. That's API security and rate limit. Okay.
Mm,
But that's the part we're not going to talk about. Maybe I can discuss something on that. Okay. You can
mm,
explore on this, like there are some security aspects of these APIs. Okay.
mm,
Uh, so some APIs are not free, right?
mm,
Uh,
yeah.
and these are like valuable, right? Do you see how valuable
Yes.
this data is,
Mm,
right? Isn't it? Because
yes.
this is
Yes.
provided by Google, right?
Mm,
It's really valuable
yeah.
to Google. So Google is bound to give it either free of cost or it may charge it, right? So
Mm,
there is some security aspect to it and also some limiting aspect in the sense this is the usage limits given on the geocoding APIs. Okay, so
mm, mm,
it can provide you 2,500 requests per day. That's free of cost,
mm,
right?
mm,
And if
mm,
you are using these APIs for business, you might have to pay something, but you can get really lot of requests in a single day, right?
mm,
So that's the usage part of it and the limiting part of it. Okay, but these are really good, and I found it really good to integrate with the Python code and get all sorts of fun stuff. Yeah. Okay.
yes.
Great. So again, it has got some authorization. See, this is like similar sort of APIs might be exposed by other vendors, other communities. Like Twitter has exposed some APIs which you can make use of. Okay,
Mm,
and it has got some authorization or authentication. So everybody has its own rules and regulations to those APIs. Okay, which you should read on before
mm,
using them. Okay.
okay.
Okay, so great. So similarly, you can also figure out the tweets done by your friends.
Mm,
Okay, somebody is in your network is doing some tweet, and you don't want to open your browser and do this stuff, and you want that I can write a cool Python code to fetch all the tweets, right? You can very well do that
mm,
using these APIs. Okay.
mm,
Right?
mm,
So you can go to the
mm,
Twitter APIs and you can see these all get requests. You see the get requests, okay?
yes.
And you can see you can, for example, this particular says returns the most recent tweets authored by the authenticating user that have been retweeted by others. So for example, you are giving a username and password, okay?
Mm,
Username and password in the Python code. All right. So basically what you're doing is authenticating your identity, correct?
mm,
Once you authenticate, you want to figure out how many tweets of mine have been retweeted, right?
mm,
Something
mm,
like that. Okay, so these are very useful APIs which anybody can use. So these are open to all with some conditions. Okay, and you are
Mm.
open to use them and create your own application, right?
Yes.
Okay, okay, this is one of the codes. I'm not going to run this. Okay,
Mm.
so you can
Okay.
go through this later. Okay, so
Okay.
what it has got
Okay.
is another library which is called TWURL.
Mm.
That's basically specific to Twitter. Okay,
Mm.
and you can run this code. I hope this should be working again like all other codes. Okay, just copy paste this
Mm.
and try to run and see what you
Okay.
get.
All right.
All right. Okay, great. So this is the output which you get out of this code. Okay, and you can see, right, the tweets
Mm.
below as the
Mm.
output, right?
Mm.
And believe me, this is a very good stuff. If you can think on some ideas, you can build an app around it. Okay,
Mm.
great. So we have come to end of today's session. Okay, so what all we discussed today? We discussed about XMLs. We discussed about REST. Though we did not go in deep about REST, but we use the REST services, isn't it? We use the APIs, REST APIs, right?
Mm. Mm.
Uh, and we discussed about JSON format. How do we parse XML and JSONs, right?
Mm. Mm.
And what APIs are, what services are, and we in fact went on in depth about understanding XMLs, right?
Yes.
Okay, great. Do you have any questions for me today?
Mm.
No?
No.
Okay,
Mm.
great. So I would expect one part from you, okay? And
Okay.
that is you run through the codes snippets which we share
Mm.
in the slides, okay?
Mm.
And make
Mm.
yourself little
Okay.
confident on the concepts, yeah?
Okay.
Okay, all right. So that
Alright.
marks the end of the session today. Thank you for joining in.
Mm. Thank you.
Have a great day.
Yeah, you too.
Okay,
Yeah,
bye.
good night.
Good night.
Bye.